So here are the notes for section 4.5. The topic here is going to be looking at graphs of rational functions. And rational functions is something that we've done before. We just we're being asked to look at different parts of a rational function in this section. So just to remind you what a rational function is, it's of the form P of x over Q of x. Now Q of x can't be equal to 0, but just remember that P of x is any polynomial, and Q of x is also got to be a polynomial. And as I said, you've actually looked at these before several times. So this is a quick example of what a rational function might look like. So 1 over x minus 3 is a rational function. So the main topic in this section is finding what they call asymptotes of rational functions. So here's the definition for vertical asymptotes. It's not really a definition, I guess. It's basically a rule of how to find it. So let's just take this function that I wrote above there, f of x equals 1 over x minus 3. So what should be familiar to everyone is that the domain is all real numbers except 3. We cannot put 3 into the function because we can't divide by 0. Now, that also happens to be where the vertical asymptote is located, okay? So I'm going to sketch the graph for this. If you prefer to go to y equals on your graphing calculator and just type it in, make sure you use parentheses around the denominator. But the graph looks something like this. Now it's going to depend, maybe what shows up in your calculator might depend on if you have a newer calculator or an older calculator, but my older one does show a line right here. And I'm drawing it as a dotted line here because it's not really part of the graph. An asymptote is an imaginary line. It's an imaginary line where the curve is going to get really close to it. The curve of the function gets close to this vertical line, but it never touches it. So a vertical asymptote is always going to have an equation of x equals. That's the equation for a vertical line. So this function, the vertical asymptote, is located in the same place as the domain restriction, and that's fairly typical. I'll give you a few pointers when it gets a little bit trickier, but just remember that in order to find a vertical asymptote, the function has to be reduced, which this one already was, so there wasn't anything to worry about there. Second thing to remember is that a vertical asymptote is just an equation of a vertical line, so that's why it was written x equals 3. And the third thing to remember is that what a vertical asymptote is just an imaginary line where your graph the curve approaches that vertical asymptote, but it never actually touches it, ever. Okay, so that's the first simple example. It'll get a little bit tougher as we go, but the next set of rules is for horizontal asymptotes. So I'm giving you the same setup, a rational function, just like we had above. Got a polynomial on the numerator, polynomial on the denominator. Now, for horizontal asymptotes, there's essentially three different rules or categories, I guess, for horizontal asymptotes. So the first type is when the degree of p of x and the degree of q of x are the same. Now what that means is, like, the numerator is going to have x squared minus 3, and the denominator has x squared plus 5. They both have a degree of 2. So when the numerator and denominator have the same degree, then your horizontal asymptote is y equals a over b, where a and b are the leading coefficients of the numerator and denominator. And I'll show you an example of that later on. The second category, the second type of horizontal asymptote, I guess, is when the degree of p of x is less than the degree of q of x. That's the easiest one, I think. When the degree of p of x is less than the degree of q of x, the horizontal asymptote is just y equals 0. So the first thing to pay attention to is what the degree of p of x is and what the degree of q of x is. And the third type is right here. It's when the degree of p of x is greater than the degree of q of x. And in that case, that's the shortest of all of them. There is no horizontal asymptote, so you just write no horizontal asymptote, or just nothing at all. Okay, I guess no horizontal asymptote is an acceptable answer. And to finish this up, I've got a couple of notes here about just overall rules about asymptotes. The graph of a function never crosses a vertical asymptote, ever. And remember, asymptotes are not part of the actual graph of a function. They're imaginary lines. They're imaginary lines that the curve approaches but doesn't actually touch, usually. It can, in rare occasions, it can cross or touch a horizontal asymptote, but that hardly ever happens. The last thing to make a note of here is regarding the oblique asymptotes. We are going to be skipping that because we just didn't take time to do section 4.3, basically. So just make a note of the fact that I did modify the assignment. So don't worry about finding oblique asymptotes, but if you want to, you can certainly read about it.